Navadiya. My roll number is 25C052 from Computer Science and Engineering Department, and our today's subject is to system saving smart energy saving room system using logic gate. In this presentation, I will explain how digital electronics can be used in automatically control room appliances to save the energy. Introduction. In today's world, energy consumption is very high, increasing very high. Energy demand rising globally. Energy consumption increasing at 2.3% annually. Automation requires smart system reduce human error and optimize usage. Smart solutions. Intelligent control system minimize wastage effectively. Traditional manual control leads to significant energy wastage. Automated digital system provides reliable, efficient alternative that adapt the real-time condition. In introduction, we saw that energy demand is rising very highly. Automation is required to save energy, and smart solution. Intelligent control systems minimize wastage in efficiency effectively. Real life problem. In our real life, lights left on, we all know when we left the rooms remain illuminated even when unoccupied, wasting electricity throughout the day. Fans running unnecessary. Ceiling fans continue operating regardless of occupancy or temperature condition. We left the fans always running on and left the rooms. Human negligence. Forgetting to switch off appliances is a common behavior pattern requiring automated solutions. System overview. In this system, input stage sensors detect occupancy, light levels and temperature. In this system, we have set the inputs to recognize the occupancy, light levels and temperature by sensors. Logic processing. Digital gates process binary inputs using Boolean logic. In this presentation, in this model, digital logic gates will be used for sensing occupancy, light level, and then after that Boolean logic will process output controls. Relay switch appliances on off based on logic output. If output comes on or off based on logic output, then after it can action to switches, relay switches. Problem statements. Key issues. Wastage energy from unattended appliances, increase electricity bills for households, human error in manual control systems, reduce appliance lifespan from continuous operation, environmental impact from excess consumption. This is our key issues for this problem statement. These problems highlight the critical need for an automated digital solution that eliminates human dependency while optimizing energy usage. We humans are very careless for our to save the energy in this critical situation. So that is my problem statement, and I am going to solve this problem by using digital logic gates. Why digital logic? Binary. In this logic, we will use binary system. 0 1 simple. 0 1 representation makes implementation straightforward and reliable for decision making. Fast processing. Logic gates operates at nanosecond speed, enabling real-time appliance control without delay. We know digital logic gates are very fast in to give outputs and appliance in control without delay. In nanosecond speeds, it works. High reliability. Digital circuits are less susceptible to noise and environmental factors compared to analog system. Digital circuits are very useful in industries and also in our real life rather than analog systems. Easy implementation. Standardized ICs like 7408 AND gates are readily available, cost effective and simple to integrate. Easy implementation. In this factor, 7408 AND gates are used by us, and it is easy to available, cost friendly, and simple to integrate. That's why we use 7408 ICs and gates, standardized, and also binary system 01 representations. Objectives: reduce power consumptions, automated control, improve efficiency, and apply logic, digital logic. Reduce power consumption, minimize electricity wastage by eliminating unattended appliance operation through intelligent automation. Second one, automated control, remove human dependency by implementing sensor based automatic switch off room appliances. Improve efficiency, optimize energy usage patterns while maintaining comfort through conditional logic processing, and apply digital logic. Demonstrate the practical implementation of Boolean algebra and gate level circuits in real world application. To reduce power consumption, we will minimize electricity wastage by eliminating unattended appliances. That's why our logic gates will uh, gives output, and our sensors will turn off and on the appliances to reduce the power consumption. In this system we will use automated control, no human dependency will needed for these systems. Improve efficiency, optimize energy usage pattern will maintaining comfort through the conditional logic processing, and apply digital logic. In this system we will apply digital logic, demonstrate the practical implementation of Boolean algebra and digital gate level circuits in real world application. That we all know. System components. First we need motion sensors, PRIs. PRI sensor detect human presence. 1 is equal to person detected, 0 is equal to no motion sensor. Light sensor for lights on and off when dark night, and 0 for daylight, sufficient daylight. Okay. Temperature sensors, digital thermometer monitors room temperature. If output gives 1, that means hot and above threshold. If we set the threshold value of temperature just like that 24 degrees Celsius, it is our threshold value for temperature. Temperature sensor, that will, if temperature goes above 24, it gives output 1, and above below, that's give our output 0, and 0 is comfortable. Digital thermometer monitors, light sensor, motion sensor, and AND gates. 7408 ICs processes inputs using Boolean logic to determine the output state. This IC will be used in this system for monitoring and to apply present the systems. Relay circuit, switches. We will, in logic gates we will use switches as appliances based on logic output on or off we control. We all know that our light fans are using switches on or off. That will, we will also use switches in this system. Input description. A, figure out. Firstly, all sensor inputs use binary representation where 1 is equal to true or 0 is equal to false. Motion input, person present, it gives output 1, 0, room is empty. PRI sensor output determines occupancy status. Night input, 1 is equal to dark, 0 is equal to daylight. LDR sensor we will use in this system. 1 is equal to dark and 0 is equal to daylight. If output of 1 gives dark or night, that's why our system will close. And LDR output controls lighting based on ambient light. Third, temperature input, thermometer reading determines the fan operation. If system gives thermometer sensor gives output once, it means it is hot or high temperature, then given threshold value. Or if it gives output 0, that means it is our comfortable temperature for system. Figure out the circuit not using the recognized, it is our AND gate. Here input A, here input B, and here input C. Here is ending of AB and output is D. Then next D and input C are ORing here, and our output is E. Here is the truth table. Complete the table circuit, indicate the logic levels of point D and A in the circuit. When points A, B, C are at the logic levels indicates zero representation lows, and low or off represents high or on. Here is our truth table: 0 0 0 0 0 1 1 1 1 A, B, C for inputs, and outputs are D, E. Draw the recognized system for AND gate. It is our task. Next, output description. Light controls. um, in light controls sensor, if conditions are there are two: motion is equal to 1 and night is equal to 1 condition. This is our condition. Actions: lights switch on automatically when person detected during the darkness. In darkness, night sensor, LDR sensor, gives outputs 1, that means it is night or dark. And motion, when person and motion are detected by motion sensors, it gives output 1. When condition is both 1, the actions in action, lights will switch on automatically. And in fan control, when motion is equal to 1 and temperature is equal to 1, when motion sensor, LDR sensor, detects any movement, it gives output 1. And when temperature detect the high temperature or give higher temperature and hot temperature, given that threshold value, it means there is a hot or high temperature, that means it gives output is equal to 1. And in action, fan activates the person present and temperature exceeds the threshold, the fan activates automatically. The system implements AND logic, both occupancy and conditions. Darkness and or hot temperature must be true for appliances activation, ensuring optimal energy usage. So now we are going to represent logic design for smart automation, exploring how digital logic simplifies and enhance the home automation systems. Our chapter 1 is understanding the logic and gate principles. Chapter 1 is understanding the logic. The core concept: logical AND. At the heart of the smart automation lies fundamental digital logic. An AND gate is a basic digital logic gate that implements the logic conjunction. It produces an output of 1 equal to 2 true, and only when of its all inputs are 1 true, otherwise the output is 0 is equal to false. The basic gate of this system is AND gate, and implements the logical conjunction. It produces the output of 1 only when all inputs are 1 true, all conditions are satisfied and all conditions are true, then it will give output 1, otherwise the output is 0 is equal to false. In practical terms, this means the device is activated only when all predefined conditions are met, preventing unnecessary operations and conserving the resources. Defining automation rules and logic. Light automation. The light will illuminate only if both conditions are simultaneously true. Motion is detected and it is currently dark. If in light automation, if the first condition is motion is detected, if motion is detected by motion sensor, and then logic will check the second condition. Currently the room is dark. If it is yes and both conditions are true, that means it will on automatically. This ensures the light is not wasted during daylight hour or when the area is unoccupied. Then when there is no in the room, it ensures that the lights is off and light is not wasting the energy during daylight hours. This is light automation system. Other is fan automation. Similarly, the fan will activate exclusively when two conditions are met: motion is detected and the temperature is high. In fan automation, that will be check first condition. If there is motion is detected by motion sensor, LDR sensor, if there is condition is true, it means that logic gate gives output 1, and then it will check second condition, that is temperature. If temperature is high or hot, that means second condition give output will true or 1. That means both conditions are satisfied and output is 1. All when all conditions are satisfied and output is 1, then true only when all inputs are 1 and output will of will 1, it is equal to true. That this provides comfort only when needed, avoiding continuous operation is in empty or cool space. If there is a cool space or motion is detected, the fan automation will not run. If operation there is no in room is empty and there is temperature is high, but it will not run automatically. These simple rules built on the logic and logic from the foundation for intelligent responsive environments. Our chapter 2 is predicting outcomes, the truth table. From truth table we will predict the outcomes, what will how will automatically it actives and it how it works. This is the truth table. A truth table systematically lists all possible inputs combinations to a logic circuits and shows the corresponding output for each. It is a critical tool for designing and verifying the digital logic MNTLF. This is our motion sensor. It is our night. This temperature. This light L, M, and T, and this is our fan for F. This is all 0. This is all 0, 1, 1, 4, 0, 1. This is all conditions are here for truth table. This is or get truth table or get no truth table. A B here is A B are ORing and output comes 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. This is a basic truth table of forget. The table visually confirms that the light L only turns on when the motion M and night M N both are 1. The fan F only turns on when motion M and temperature T are both 1. Here is the table column of M. When motion is 1 and light L is 1. Here 1 and 1. That means motion and night will 1 1. That means output light is 1 here. Otherwise only motion and motion is gives output as 1 and but if there is no night, then will no output for light. As like that our temperature, it gives output 1 in room temperature in room temperature is high or hot, but there is no motion. Here it is 0 but temperature is high, but here no fan is activated, means gives not output true. But when both are 1 and 1, that our gives us output 1. Here also it gives motions is equal to 1. Here temperature is equal to 1. It gives our output is 1. These are the basic funda of temperature and motion when connected to fan, and night and motion are connected to lights. From concept to reality, the circuit diagram and logic. Two AND gates are process sensors signals. Sensor inputs motion, light, temperature sensors. Relay output, drive light and fan. Sensor inputs, sensors will input motion, light, temperature sensor as we know and we see previously. The sensors will take output here logic process and relay output. In output the light fan will run as relay output. The diagram illustrates the physical implementation of our smart automation logic. Sensor detect environmental conditions. Their signals are processed by the AND gates and the output triggers relay to the control the fan and light. Our chapter 3 is seamless operation, the working process. In this chapter we will see how this logic and operations are working. Firstly, sensor input. Environmental sensors, motion, lights and temperature continuously monitor their surrounding, converting physical data into digital signals. Our sensors are continuously monitoring their surroundings in motion, light and temperature. They continuously measure the temperature. They continuously check the lights is light, night or dark, and continuously monitor the motion. If there is any motion in movement, or that will gives check and gives output. Second is logic processing. These digital signals are fed into the AND gates. This surrounding converting physical data and into digital signals, and these digital signals are fed into AND gates. In this system, we will only use AND gates. Then that signals are given to AND gates, where the predefined conditions are evaluated based on the logical rules. In AND gate, we have set the logic for the predefined conditions. If that both conditions are satisfied, that gives our output according to logical rules. Third is output generation. If all conditions for appliances are met and the AND gate outputs gives a 1, actively a relay which in turn powers the respective device, light or fan. If all conditions are for an appliances are met, the AND gate outputs gives us 1. That means the which in the turn powers the respective device, light or fan. This continuous feedback loop allows the system to react dynamically and ensuring the appliances operates only when the genuinely required. That in this by these all conditions, we are saving the energy and stopping to waste the energy by our human dependency on systems. And yes, this feedback loop allows the system to react dynamically and ensuring the appliances operates only when genuinely required. Real life impact on automated room scenario. Entering a dark Here is the scenario of entering a dark room. Motion sensor detects a person entering. Light sensor registers the room as a dark, and AND gate receive both signals, and motion is equal to 1 and night is equal to 1. The result, light turn off if both conditions are satisfied and both sensors are detecting that person is entering and room is as a dark. That means both conditions are true, and in result the lights turn on automatically. When the person leaves, motion ceases and motion is equal to 0, and AND gate causes the output becomes 0. In AND gate, we all know when both conditions are true 1, that means then output will 1. Otherwise, one of them will 0, the output will 0. The become output 0 and the light turns off automatically, and it is saving the energy. This is a real life impact. An automated room scenario is entering a dark room. Our chapter 4 is broadening the horizons, diverse applications. Smart home, office workspace, hotels and hospitality, classrooms and institution. Smart home, optimizing the comfort and securing through the automated lighting and climate control and security systems. Office and workspace, enhancing the efficiency by automated adjusting lights, HVAC and the power to occupied areas. In office and workspace, all areas are not occupied for the work, enhancing by efficiency. That saves the energy and automatically adjusting light where there is no needed for light. That means in that area light will automatically off. And yes, hotels and hospitality, improving the guest experience and reducing the operations cost with smart room controls. If we install the smart rooms controls in hotels and hospitality, the guest will experience more privilege and experiencing high and reducing the operational cost. In this is our main concept to reduce the cost of operations. When hotels and hospitality are very expensively to this factor, with we can reduce it by with smart room controls. Classrooms and institution, creating energy efficient learning environment that respond to occupancy and ambient conditions. Unlocking benefit advantage of smart automation. Energy saving, significant reduction in electricity consumption by activating device only when necessary. If we activate devices when it is only necessary, the electricity bill will consumption and will reduce, and significant use of electricity. It saves the energy and reduce the waste of energy. Second one is easy to use institution operation that requires no manual intervention once or configured, providing seamless convenience. If we install this system easy to use, we have no any required or manually to turn on and turn off the system. It automatically runs on sensors, eco-friendly, reduce the carbon footprints through the optimized energy uses, contributing to environmental sustainability. This system is our is eco-friendly and also budget friendly. Reduce the carbon footprints through the optimized energy uses, contributing to environmental sustainability. Cost effective, yes, as I say, these lower utility bills, electricity bills, and reduce the wear to tear on appliances lead to long term financial savings. These savings will help us in long term and lower utility bills. That also affects us on savings and financial conditions. The path forward, future scope and conclusion. Future possibility. The potential for smart automation rooted in digital logic is vast and growing. IoT integration, connecting with the broader and networks of smart devices for more complex scenarios. There is, we are connecting the broader networks of smart devices for more complex scenarios. There will be in future. This future is full of automation, smart automation, and rooted in digital logic. Also, mobile control, remote management, and monitoring of home system via smartphone and tablets. In right now, this 2026, there are many system and management monitoring systems, home systems are available in market to control and remote the monitoring systems via smartphone and tablet. We can operate the whole home system by our one click in mobile smartphones and tablets. This is mobile control and automation. Smart city, expanding this principle to optimize public infrastructure and traffic management and urban services. Extending these principles to in smart city and publicly infrastructure and traffic management and urban services. This project, our conclusion is this project demonstrates the power of digital logic to create intelligence and energy efficient and responsive environmentals and shaping the future of automation. This project is demonstrate for our future automation and shaping the responsive environment to save the energy and energy efficiency and create the intelligence and shaping the future of automation. So that this is my presentation for digital electronic study.